chief digital officer and all, their main concern is that whether money is utilized effectively. And the whole discussion is that how innovation, the landscape is changing, how the companies are operating on their innovation and R&D space in a bit different way using the different tools and technology. So what are the priorities and what are the things that are driving for the innovation leaders? So first is that digitalization in software. If you think about 20, 30 years back, let's take an example. Suppose Unilever coming up with some new soap. What will do? Different kind of chemicals you will mix, you will test it, you will try it, then you change the composition, again you build it, test, try it, you do some laboratory environment, you do some chemical testing. So that is the way that is the process that you build a new product. But now, do we really need to do everything that physical testing and physical build the product? Maybe no. How we can take the help of digitalization and software. So that's the how we can accelerate our innovation using that. So that's the one key driver. Second part is that global engineering platforms. You know that many companies, they are outsourcing or they are putting their development center in India or some other countries. So majority companies, they're transferring their workforce from high cost country like Europe and America from there to Asian countries or even Latin American countries, some low cost. So how the transfer happens, how the knowledge, it's not only the work transfer, the knowledge transfer, technology transfer. So that's a heavy work is happening in that area. And other important thing is the sustainability. Everybody is talking about sustainability. Every company need to show there's some sustainability goal. Even consumers, they are getting quite aware about sustainability. So when they buy a product, they kind of look into that whether products built in sustainable way or not. So companies are investing money that how the to take the angle of the sustainability when they do the product development. So these are the main key drivers. Again, I'm not telling this is the only drivers. There are many other drivers there, but where innovation happening, that again, if I summarize, that utilization of the technology to innovate faster, utilization of the workforce in a better way or efficient way, and then transferring the knowledge so that they can help in the innovation. And third factor is that sustainability, how the new innovation can help to improve the sustainability of the product, sustainability of the company, the net zero target, all the different things we are talking about nowadays. So what is now data and AI doing actually? Basically, it is helping reasoning, modeling, computing. So based on the data, then it also doing the generative AI power and then the AI MLs and create the model, create the something like a extrapolation and try to derive something mathematical way rather than always creating the different type of products and physically and then testing it out. And overall, what's the achievement? Basically, correctness. Faster we achieve to the correct result, what we're looking for, precision, what kind of test or what kind of result we are looking for, how precisely we can meet that. So that also helps technology, and also quality. And that comes bit of R&D phase and bit of in the operation phase also, that technology, how helps the overall quality control. Now, if you look into that, as I'm coming from consumer product industry, or even if you talk about life science, because after COVID and all, you know, that different life science companies and all, they are also quite important. And we all little bit of awareness we have that how new medicine is developed, because COVID time, we all were hearing lots of newspapers and articles and all how the vaccine development was happening. So what are the things in this industry, life science industry or consumer product industry, that products need to be healthier, reduce plastic waste. So when I talk about product, it's not only product packaging also quite important, because I don't know India how strict nowadays. I'm not closely following that India rules and regulation, but in the Europe, quite a lot of restrictions in there in packaging, how much plastic can be used. So definitely they are also technology plays role, and I will give some definitive example actually. Cruelty free. If you know the old days, if you think about any medicine or pharmaceutical, you will think like if we develop some medicine, then we'll try on guinea pigs and all. We all know that is the very traditional way when in our college days, university days, biology, doing the experiment on guinea pigs and frogs and all, we have done it. But now, world is going for cruelty free. So then rather than physical testing, in mathematical model, if we can test it and prove something, then that way the cruelty free product development is possible. And then when you talk about sustainability, definitely it's the energy and also the lesser use of water. So those are the kind of parameter that what is the driver that product companies they're looking for. And again, they need more help from the technology to achieve these goals. And again, there can be many more. Here are the few examples only. So what is the now R&D is changing now? So from traditional R&D to data-driven R&D, because we are heavily relying on data, not that physical product, physical thing. So first, traditionally, R&D was looked as a cost center. Yes, every company need to spend some money, just like they see as a cost center. But now R&D is a growth engine because market is competitive. Same amount, same kind of potato chips available from multiple companies. Then which company's product you will buy, which test you will generate. So that is how it is come, that it is R&D actually. So R&D not necessarily means when I say R&D, yes, we think about a rocket. We're developing some rocket or we are developing new type of aircraft. Yes, those are definitely R&D. But R&D also, if you think like a chips, potatoes are manufactured in different part of the world, but you go America or you go in Southeast Asia or you go India, you take a particular brand's international brand's chips, you will find the same taste. How is it possible? So there is some R&D work, something is happening. And so it's a growth engine and also then some differentiator. So why you will buy one company's chips rather than buying the chips from another company? And there are also some differentiating factor and how this can happen. You can achieve that using the R&D, data-driven R&D. Then talked about that physical experimentation manual process, which used to do that earlier, and repetition of things. That is, one is the wastage of time, another is the wastage of the material also. But now with the data-driven R&D, with the mathematical model, we are minimizing. I'm not telling that we are not going to do any physical test. We'll do it, but we are minimizing that. That helps to speed up, so shorten to go to market, and also it helps to reduce the cost. And then other thing is that this is from pure product development side. Then new product, what's the customer like? What suppose you try some new chips in the market. Somebody say, I want more salty, I want more soury. So how to create that? So getting the data, not create only, getting the data, analyze, and then create your what kind of test you want to achieve. So that is also, so it is not only the product development, the creation of the product, but getting the market feedback, analyzing the data, and from there derive that what is the final product you are looking for. They are also, data plays a role. And that also, again, the competitive world, that is quite important. That is. So data again, how the data using and what are some examples here. So it's the experimental results. You have the data, you need to store in a central place, because if we are talking about that many companies outsourcing or they're putting their development center in India or Southeast Asia or Latin America and these countries, and then they have the global headquarter in European or American countries. So then you need to have the data accessible. It's not that one lab, five scientists are working together and they're exchanging and talking to each other across the table and finding the exactly who has achieved what result and tomorrow what to be done. So 24/7 people are working throughout the globe. So whatever the result they find in India before going home, say they captured that everything in one data lake, and then person in Latin America comes in and continue the same experimentation. So that way it become very important that how the data is getting shared. Then Social data, I talked about that market, what type of flavor people want. And I'm taking again consumer good example. It can be, you can elaborate or extend that example to any other industry, any other topic. But as I'm coming from consumer goods, so I'm taking that example. Or you are using a soap, what kind of flavor, what kind of fragrance you want. So those are available in social media and multiple other places. So social data is important. Compliance and safety related data important. When you produce some toothpaste or will produce some consumer health product like energy drink, it has to go through some regulatory, and you need to have a capture that the source of the each of the ingredients and how you are combining, what chemical reaction, what's the final result. All these report you need to publish, and they are also, it's again matter of data. So then marketing data, we talked about environmental data, that water usage, your energy usage, your carbon footprint. So that also important. So data is everywhere. And if you think pure from R&D perspective, or even if you think from overall industry or company perspective, we need to measure that data. Not only measuring that data with the measure, then you need to take some action, you need to optimize. And that is where what we are capturing and how we are exploiting the data. So it's first of all, this is a big role also. It's the how you capture the data. So we do a lot of work on that also. That it's not only we talk about AI and all this ML and all this, that is the final result, the final tools. But before that, how to design the architecture, how the companies can share the data from one unit to other unit and maximize the utilization of the data. So that is one important aspects we need to concentrate, and we are working very much in the industry. Then knowledge management, data platform on the all this architecture. Then it comes the exploit the model management, how you do the data science platform. We modeling the product using based on the data science, not the physical testing. We do that. And then automation. So many things we do the automation when people are not, suppose regulatory thing. You can do the automated way that certain things, certain parameters we know, and then after testing the test result, automatically it can say that whether product is complies with or meet all the compliances or not. So that level automation is possible also. So the left hand side talking about what are the data, why we need data, and right hand side talking about how to capture, how to store, how to use it, and how to maximize the usage of data for the better product design, better way to meet the regulatory requirements or safety requirements for that purpose. Now, few kind of quantifiable benefits which we have seen from industry perspective. So 20% acceleration when we do the product testing and product development with the help of the data rather than all the physical testing, that we have seen the 20% acceleration in the discovery phase. Then we have seen the uh, automation and all that help. It improves the double the experiment capacity. So same thing actually here is how fast you can launch a product, and here how many products in parallel you can work, because your workforce gets freed up because you are using the tools and automation. So then you have to improve your capacity the double. Then packaging I talked about. I have a specific example. I talked about the packaging. So how we achieve the saving the plastic by creating the alternate materials, and which has the which are having the plastic kind of features and functionality. So that way we're helping. So from sustainability perspective, and then uh, also the 87% of the user changing the habit. So people go with particular brand, particular things, but then they're missing something. They're looking for something based on the market data, that analysis, and then creation of the taste or creation of the what flavor they're looking for. And that way you are helping people to change or try the new product. And that's why if you see the market that if you think 10 years back, we didn't have so many different flavors of tea, but now we have so many different flavors, and how those are created, again use of data, and we are more and more those kind of flavors you will see. And then people are nowadays means earlier people used to talk only, suppose in India and Kolkata maybe the Darjeeling tea, but now you will see that people talking about different fruit flavors, different other flavors, teas, and all those are getting quite popular, and all these different products are being created, and how this is happening and changing the people's habit. That is also the influence of the technology. So these are few quantifiable benefits we can already observe. Yes, lot to be seen, but these are some early days, some signal that how technology is influencing the behavior. So this is again a survey. When I say lot to be done, so we have done in different industry kind of survey that where companies are there, from the investment or maturity perspective, that usage of technology in the product development. So left hand side means in the they just started. We have started, and they see some potential with the generative AI or AI technology. And right hand side is that they are fully utilizing and fully functional. And you can see very few companies or very few cases, only 6% or 16% cases that they are in the full maturity level. Most of the companies or industries are in this space. It's a definitely survey result and based on our studies, but definitely you can use it as a reference. So it's a very early days, and technology is going to influence way more in another 10 years time, or even in the near future. Let me skip this. Okay, now few specific examples, and I will go deeper and deeper with the different examples. So first one is the pharmaceutical company. We work with a pharmaceutical company that there are thousands of different drugs and candidates and all there. So identifying, so it's a more generative design, the new drug compounds, how you design and that and all that, with the full integration of rapid identification of solution of the drug design. And we started using the technology for the, basically we are working for a pharmaceutical company. We're helping them to develop that technology. And there are thousands of drug candidates, and you need to from there select the which technology to go. So earlier, which could take few days and weeks, and you can find the solution in less than 5 minutes now, just applying the technology. So that level benefit we achieved. Then let's talk about, I'm not going to talk each and every example. So let's talk about the third one. This is talking about technical publication for the oil and gas company, but let's leave it. It's not the technical, it's not only the oil and gas company, it can be any industry, lot of product documentation, a lot of manuals or regulatory reports need to be published. Normally what happens, people are working, referring to 30, 40 or 100 other documents or other reference data. Based on that, they create a document, and it takes maybe 2 weeks, 3 weeks, 1 month, depending on the complexity of the document creation. But if we can use the Gen AI and AI technology, we tell them, okay, these 20 documents need to be referred. These are the information to be captured from all these documents. And this is the report structure of the final report. And this is the way the final document to be produced. Then we have seen actually in this particular case that what documentation could take 2 weeks of a person to prepare. In few hours time, with the help of technology, such kind of documentation is possible. And documentation sounds like okay, not so important work, but actually when you design a product, and it can be pharmaceutical, it can be consumer products, it can be automobile industry, it can be aerospace industry. It's a quite important task actually, documentation. And that documentation, it can be done with so much time we can save. That's a significant benefit we are achieving there. Other thing is that software coding. Quite a few different products, we have a software programming is involved. There is a software component is there. And we have many companies are working, not specifically us, that, there are old legacy software there. Those softwares are not cloud ready. You need to modernize the software. You need to rewrite the software in a new programming language, new coding language. And we can use again AI technology and Gen AI to write the software coding, not that everything the human engineers or IT developers need to write on their own. Yes, I'm not telling that there no developer is not needed. I'm not making any such extreme statement, but definitely quite a lot of optimization is possible. Some basic code writing or some modernization of some code, some old programming language to latest modern programming language to upgrade. And these are not just a talking points. We are already doing that in the industry with many product companies. We are helping them in that area, in this area. So few other examples here, but I will again jump few specific one. I will talk smart sensory. So I have another example later I will talk about. See, I give example of tea flavors. When particular tea flavors is generated, or in a particular soap, someone coming up with a particular fragrance, how it is happening, that how we know that what fragrance consumer will like, and what are the combination and how we derive to that fragrance. So everything is a data driven. Or if we're developing a particular taste of a tea, we know that how much bitterness, how much sweetness, how much all the different taste flavors are there, and we know different components, different leaves, which one carries what level of taste, and how strong which one from the bitterness perspective. Another leaves may be strong from the sourness perspective, and then how we combine and with the mathematical model, and we try to derive or develop the new flavor of tea. And then we also have a market data what clients are or end consumers are looking for, and then we try to achieve that flavor with the help of the modeling through AI. Then we talked about virtual packaging. We launching a new product, and that what should be the packaging. It's not that we physically create the package, we test it, try it. So we do the virtually, we design the packaging. So packaging can be, it's a color and filling and look, and also packaging can be how to fit it within a box or maximum way, that logistic perspective, that maximum container can be fit within a box, how we can do that. And that is all, again, everything is done nowadays in a data driven, utilizing the data. Based on the data we are designing, rather than creating too many physical products and testing and then feeling that whether it is right or not. Then I'm just checking which other example can be interesting. Yeah, automated compliance. We talked about compliance, that there is a compliant formula, and from the beginning we can fit that and we can develop the products. And specifically when we work with a client who are in the life science industry, in the consumer product health industry, when anything, any creams or any food products we are talking about, there is a lots of compliances, and even things become even more complex, that different country or different region has different compliances. And if everywhere it needs to be that physically try to fit within their compliance limit in that particular region, then it is a cumbersome work. And that whole thing can be simplified with using the data. If we know that these are the safety criteria of this particular region, then what component, how we mix and all, everything can be data driven. We can change the composition, then we can still keep the similar flavor or similar end effect, all possible. And all these things are testings and all. Yeah, it is done using the based on the data. We are doing that. Yeah, here is the example I was talking about. I gave the example of tea companies, that we worked with one tea company for creation of the different flavor. And there are multiple, when I say multiple, it's not 5-6 components we are talking. It's a thousands of different ingredients are possible, and how the mix and how the combination for each ingredients, there is a catalog on different taste buds and different flavors and all what are there. And then I guess it's background noise, yeah. And combining that, how we are creating a particular flavor, we are doing that. And similarly here with some ketchup, we develop that. And you see the what we measure objectively, that pH value, viscosity, acidity. So these are the kind of, it's not only, I was giving example only that how sour, how sweet, how bitter, but not only that part. It is more even the acidity, viscosity, then many other parameters are involved actually. And then with that, with the help of the data science, with the lots of data, we are helping them. And what one tea company we are discussing, that certain tea flavor creation, it may take for them 2 to 3 years. And with the help of all this technology, in 3 to 6 months time, they can develop now such kind of flavor. So that is how the technology is helping the generating the new products. And definitely one is that faster product launch, and other thing is that you need the less people. You don't need that so many testers and all that. So that way also it is helping. And also sustainability angle, if you see that if you have to produce all these different products with the different combinations for over 3 years, then so much wastage you are creating. But here you don't do the physical development of the product. Everything you are doing based on the data. So then you are saving there also. You are not you are reducing the wastage, and that way you are also contributing in the areas of the sustainability. I talked about packaging. So why packaging is important, and it is any industry actually when it comes to consumer product industry, life science product, that because packaging is not only the look and feel, because certain medicine maybe need to be in within the certain temperature. For that you need some special packaging that in a carrying time with some heat, it does product quality doesn't get deteriorated, and so you need to select the right material. So that's why packaging is a quite important area. And here how we can utilize the technology, and we how this can help. So first of all, to understand that why packaging is the very important one. That so see that here example, if you see that recycling, if you do the recyclable material with that, the we can help actually the technology that more usage of the recyclable materials and all. Then reduction of the packaging material, because you can do the protect certain product, you can design, if you don't do carefully, then you can put lots of packaging material. So one is that definitely product cost is goes high if more packaging material is more cost, and then end of the day consumer need to pay more price for the product. And other things that packaging is the end of the day, one product is used, then what happened, packaging is a people throw away the packaging, so it is a wastage. So if you can reduce the packaging material, so that also will help you in the saving, reduce the wastage and saving the money. So that is also important area. Then innovate and perform the system change. So there are sometimes we need a plastic, and the plastics those are not recyclable and all. So creation of the new material or new things. So that is again, instead of using the proper chemistry lab and doing the proper chemical experimentation and then come up with the material, so we can do many things using the data, and we are doing that. So that is how we are contributing. The packaging area is quite important, and packaging is very important, that area. You can see that if average is that the $1 is the packaging cost for $11 products normally, that's the kind of average that what we have observed. And yeah, so this is, see the size of the packaging market. So even it may sound like a packaging is not so important, but usage of the data, selection of the right material, optimizing the packaging, how we can optimize the industry, which is this is talking only about FMCG. It is not talking about other industries. Such a huge industry, how we can optimize there. So yeah, I already talked about the packaging. One is the sustainable, identifying the sustainable material, how we can use the sustainable way the packaging. And it is not only the material, that using the less packaging material, that also contribute to the sustainability. Then cost, significant cost reduction, that if we need to achieve certain temperature control, humidity control, how we can do that. So again, usage of technology, we can derive the better way to managing the cost in the packaging. Then speed and efficiency. So one is that fast production of the packaging material. Other thing is that efficiency. Nowadays, with the IoT and other technology, even the tracking is quite important. So we select packaging material with some small chip there, and how we can track the particular material, how from factory then delivered to the end consumer place, and tracking the material. So that is also, they are also technology, and how to introduce that technology, the tracking devices and all inside the packaging material, and how still keep it a thinner material and low weight. And that is where also we are helping to building that efficiency. And finally comes the compliance and the regulation topic, that packaging also different country has different regulatory requirements packaging related. And that can be again the packaging material related, or that can be the product related compliance requirement, that how to control the temperature, humidity of the products, some medications and all, and the packaging, innovative packaging material, how we can control that. So that also, these kind of topics also addressing through packaging in the compliance and regulation related. Here, couple of examples. One is like, this is a simple one, some automobile company, automobile parts manufacturing company. You can see that using the data, what is the best way, what is the package size? Suppose a particular component, 20 components, we need to put in a one box. Then what is the optimum box size? How they should be fit? Which way what is the layout? So there also we can use, and whether 20 components in one box is the best design, or 15 putting. So it may sound very simple thing, because I'm trying to give example in a very simple way. But then if you start considering, there are so many different other parameters that there, then it get complex. And then it comes the data science and with the algorithm, and then how we can do the best or most optimum packaging we can do. And this one talking about, for one of our clients, we did that. It was initially like a 17 plastic bags there, and we did a new packaging thing, that zero plastic bag. So these are both a specific project we achieved, that how many parts we are putting in a box, more number of parts, so lesser number of boxes. We optimize that, and here we reduce the usage of the plastic. Then here, another very interesting example. I think many of you know that like Costa Coffee or Barista Coffee, and then coffee cups and takeaway coffee cups and all that. And the coffee cups, what happens that we may think that it's a paper cup, so there is no plastic, but it's not actually true. There is still a plastic layer is there. Although we call it a paper cup, but maybe thin layer, but still there is a plastic there, so that you can hold the cup and coffee is not leaking. And we work with our particular client and derive the material, and we need to see that, okay, coffee, there will be some certain temperature, so it should be able to sustain that temperature. It should have a plastic kind of feature. It will not leak, but same time it is biodegradable. And we help that, we work that kind of packaging. So this is also part of a packaging, that how the new coffee cup being designed, and that is we did. We are not coming with a chemistry expertise or something like that. We are helping coming up with a tool which works with a chemistry specialist or other material specialist, and working with them, that combination of different materials, and deriving the new material that which can meet all the criteria they need, and help in the better sustainable packaging, but still do the job for holding the coffee in a cup. So this is similar. Other examples we do in the waste collection, some bags, and how we derive the better material for that bag. That those are sustainably right products. So yeah, so far I was talking on the R&D topic, that mainly research, the development of the new products, development of the new material, and how we are helping to create new products, and also how we are helping to create sustainable, or sustainable way we are creating the new product. So that's the key thing. So not only helping to develop a new product, but we are taking care of the sustainability part also. Now, a little bit, next 5-10 minutes, I will touch on the operation part, because not only the product development, one-time research work and all we are helping, but we need to work on a continuous basis. Then when the production process it gets, and how data can help there. So first of all, what happened in a factory, if we do not have enough data, or we do not know how to use the data, then we do not know what is happening in my factory or in my operation. We cannot predict that what may go wrong, and we cannot control it also, or we cannot improve it also. So that is where what data helps. Data can help sometimes some past failure happens, then with some root cause analysis, and with that we can ensure that future same problem is not happening. Then we can identify certain key performance indicator from factory efficiency perspectives. Like we have a one critical parameter we call overall equipment efficiency. We measure, that's a KPI. Any factory, they measured that, because factory there will be some machine will go down because of planned or unplanned maintenance purpose. Then sometimes material is not available, that's why machine is idle. Sometimes operators are not available, or operator got sick, or maybe he's off duty but machine is sitting idle. So those are the different parameters. And so this is just, I'm giving example of one KPI. And if you define like this kind of KPIs, that these are the things I want to measure in my operation, then you know what are your source data, then you know how to optimize it. So there it comes then again in operation phase, collection of lots of data, creating some algorithm. With that, one is that analyzing the past data, also for the prediction of for the future, that okay, my overall equipment efficiency for this month, maybe I have a low product demand and it will go down. So maybe I don't need to run my 20 machines, maybe 5 machines I can shut down beforehand. Not that we operating the machines that are not enough production happening. Then we realize, oh, I'm losing, and then I go switch up, but already you made the loss. But you are doing you have some your KPIs, you have some parameters, you know that these parameters are going to change and this is the trend. And based on that, you make some adjustment. Or I give another example. I'm working with one client. So they produce the liquid soap. Liquid soap, when you use you have a spray gun and from there it gets sprayed. But sometimes that company noticed that some of the batch, it happens that when they spray, it's not coming out properly. Then they realize that liquid soap, if bulk density is varying, then when it sprays, that the particle size is bigger and then spray is not coming out properly. Then bulk density, how it influenced, and then look their operation, the whole manufacturing process. It goes through different processes. In simplicity purpose, I will say suppose 6 different machines or 6 different process through it going through. And then somewhere temperature gets little varying. Somewhere maybe it goes through some nozzles, and maybe nozzle thickness is keep changing because of the wear and tear purpose. So then they're getting lots of data. And then with the data, with the analysis, they found, okay, if these are the parameters I need, or these parameters if getting changed, then the soap bulk density is getting thicker, and then it is problematic. So then you don't need to produce the full batch, and then you realize that, okay, this batch I cannot use because spray is not coming out properly, because you know what are the parameters that are influencing. You keep tracking on those key parameters, and anything happens, suppose nozzle wear and tear reason, nozzle quality deteriorate, you change the nozzle. Or maybe nozzle mouth, there is some choke because some accumulation of some material or some other things is not coming out very clean. You have to clean it, so operator can go clean it, but you everything track them based on the data. So that's where data, the artificial intelligence, and that algorithm helps in the operation phase also. I'm just giving some few very concrete industry examples and areas where we are working. So yeah, so what's the benefit again that or how it is happening in the industry? So first of all, many companies, it's very early days. I'm talking, it may sound like, oh, it's a lot of maturity there and a lot of companies doing. Yes, a lot of companies doing, but mostly in a surface level, mostly in the discussion level. Real implementation is not that many. So only 13, again, from our survey result, it's only 13% companies, 13% have scaled AI throughout the multiple teams. So you can see that many companies, they haven't done it. Then 78% organization implemented AI to increase the operational efficiency by more than the 10%. So here is the some benefit they have seen, but only the company who have done it is not that 78% companies in the industry, they have done it. So only the companies who have done it, they see some benefit, they can already realizing the benefit. Then 3 in 4 organizations in implementing AI increase the scale of the new products and services by more than 10%. So again, it shows that it definitely influencing in the business parameters. 79% of the organizations implementing AI generate the new insights. So definitely who are using, they are getting the benefit here. And then engaging with customer also. 75% organization using AI enhance the customer satisfaction by more than 10%. So wherever you are using the AI data, you are collecting the data, you are analyzing, and you are creating the new product. Like I said, the bug density vary and the spray not coming out, all based on the feedback from the market and all that. And then you are implementing that inside your company and taking some measurements so that you improve the customer satisfaction. Few more examples that few more benefits can be achieved. So one is like a oil rig, the corrosion of the materials. You can do the algorithm, the data driven way. Actually, you can predict or you can extend that oil rig assets by taking some measures that when it can get corroded or what are the things or measure you need to take. If you, by taking the early measure, you can extend the life. Then here example of a forecasting AI to use the production target. Yes, the gas provider, they're generating the gas for electricity purpose or for any other purpose or home heating purpose. And here you can predict, you can help the proper forecasting. That way you can control your production. So that way, again, it's helping in the overall operation purpose. Then aircraft industry, we see a quite significant influence. One is the production purpose we had see, and also aircraft. We are recently working that wind flow and wind direction. We can, using the AI algorithm, we can make the more prediction, and with that prediction, with the better knowledge, the air traffic controller can guide better way to the pilots, and that way it can save the fuel. It can improve the fuel efficiency of the aircraft. So that is in that particular area also we are working with the AI driven the wind direction measure and wind flow measure and how we can create the more better efficiency for the airports and airport traffic controller to improve the overall fuel efficiency. So yeah, so I can keep going and keep going on different examples, but hopefully this give you a bit of a overview that how AI technology and helping in the industry operation is first part. I was talking mainly in the R&D side, and here I'm talking about industry operation. And operation, when I say, it can be here example like a gas or energy sector. It is a aircraft industry, aviation industry. We're talking about improvement here. We are talking about like a oil rig industry. So yeah, like a piping design. When you do the by proper optimized design, the with the liquid flow and all that. So there also you can improve the savings for our customers for the water industry, because water industry is our client also, and we are helping their improving their efficiency by designing the proper pipe design and networking design with the help of, again, data driven designing and all. We are helping them. Example of I think earlier I already spoke about the potato chips or flavored example. So again, one is the size. If you buy Pringle chips, you will see each and every chips are in the same shape and size. How it is happening? And I told earlier that potatoes are coming from different farm, so all are different shape and form. It's coming, but it's come into the some same flavor and same shape and size. And how we are doing it and designing, and what is why we companies come up with such design or such shape. That also based on the consumer feedback. So flavor based on consumer feedback, shape based on consumer feedback, and then the chemicals, what kind of chemical compositions are we should use, or what kind of recipe we should use to create the chips. So potatoes may come from different plant, but same still produce the same flavor. How is possible? So again, with the help of the data, with the algorithm, we can prove that, okay, for if potato comes from this farm, then this is the kind of composition or the recipe. If comes from different farm, this is, then it's maybe more soury, so we need to change the composition. So everything is a data driven way it's happening, and we already worked with some of the clients with that. We talked about the drug manufacturing, how it can speed up, and I'm sure we all have noticed that in COVID times that how first normally vaccine creation takes so long, but how we did. Yes, there are many other things also happen. Not everything is on technology, but technology also played quite significant role to come up with such so fast vaccination or new vaccine to prevent COVID for COVID time. So you can see we all kind of seen that real application of that technology in that time. Yeah, so there are plenty of examples, but I hope some of these stories, some of these example, you will find it useful. You will remember. I'm sure maybe some of those is known to you, but some new examples you find today, and I'm sure in your university work, research work, project work with your client, you will come across this example or similar type of, then you will be able to correlate what I'm talking, and then you will be able to think from here that with the data modeling and with the data, with the help of data, how you can do your next project and delivering the result what different industry, different companies may expect from you. I stop here. There are a few more slides and examples, but we can. This is for harvesting purpose. How we can using the AI, then how the watering should be done. We can do that. That based on the air humidity or based on the looking into the plant, but visual aspect we can identify that humidity and what level and when we need to do the watering for the plant or we need to spray some chemicals and all. We can identify that. So there are on and on different examples, but my purpose in today's call is that to give some flavor, give some examples, and I try to make those examples in such a way that we can correlate with our day-to-day life so that when we link it, then technology is very easy. Then we can we can feel all excited about it. Otherwise, it may become very theoretical, very mathematical model. We know we need to do it to passing the exam, but we don't know why are we doing. And that is why I thought maybe some of the real use case I share, and that may give you some excitement. So I pause here. I see 5 minutes, and intentionally I'm pausing 5 minutes before. So if any question or any point for anybody wants to discuss anything. Or any feedback. Hopefully, if, you found it useful or
There
able
is
to.
one question in the chat box. If
Okay.
you can see it, or shall I read it out?
Now let me have a. Yeah, I'm reading it now. Yeah. Okay.
Okay.
First question from Shubhashree Roy. How can students start learning basic analytics without any prior experience? Okay, I'm sure here a lot of faculty members are here. I will say basic analytics definitely need to learn some basic technology, and we can start with a very simple examples like a like a last 10 years weather, and based on that forecasting the weather for next year July, and these kind of lot of small problems are there. And then basic Python programming, I think for all of us is quite important, especially the young budding engineers who are coming up. So for them, knowing bit of Python and with the Python coding and playing with the data, main thing is that pick any real life data, that is a 10 years data, that is a maybe, I don't know, 1,000, 10,000 data points available, and create some use case. Okay, I want to predict this, I want to do this, and then learn Python language, and then on your own, or any student can on their own can. It's like a game actually. If you enjoy like a sports, like a video game, if you enjoy that, you will see the fun playing with the data, playing with it. Because when in my or our younger days, we used to do with the statistics. Yes, data science, AI, it's the next level of statistics only. But now we have the with the Python programming and with that. So that is how I will say that any learning, it's a bit of basic techniques need to learn in university course. After that, who wants to master how much and all that, depending on how much he wants to play with the data, writing some programming and see the results, and then see whether it makes sense or not, and then fine tuning that, and that basis we can do. Then next question, if student want to collect data for their own small project to practice, can they collect from some open source sites? Honestly, I would not know that, because for most of our projects we do with the industry, the companies. So we get the data for our clients. They have some basics data for the factory data, their research laboratory data, and based on that, we derive it. But I'm sure there are open sites available, and I'm sure maybe someone else may know. But my advice will be if students reaching to second year, third year, it would be best to work in some industry, because as I'm living in UK and I see here this is the practice actually. After second year, even some students they go for 1 year for full industry job, then they come back and complete the course. I know in India maybe things are not that level yet, but still the best way to get the data and do the real life project with some industry companies, and then you get a real life problem. Because otherwise what I'm talking about, weather forecast, these are okay definitely to brush up the knowledge, brush up the skills, we can do it, but after a point it may become a bit boring. You may not able to link with the real industry um, applications. So best my recommendation will be in Kolkata based. And I'm sure, actually speaking, companies are struggling because company, their aging resources, current resources, all may not know or they not may not even, mostly they do not know the AI and all that applications of that. But companies are trying to, and I'm not talking about IT companies, that IT companies, they know it. But if you go to any industry like somebody producing some biscuits company, suppose India, in Kolkata, there are a lot of small biscuits companies or some bakeries, a lot of manufacturing the breads. And if we do some project that the bakery production improvement, or maybe taste improvement, or for biscuit companies, biscuits crispiness improvement. I'm just giving very random examples. I know it's very easy to say, but best way to learn is that approaching those kind of companies and doing some with the university collaboration, doing some projects. So that will be my recommendation. And last one is that with this level of data reliance, how you are ensuring data privacy ethics. Yeah, data privacy, again, that's a definitely very big topic. We corporate world, there are a lot of data related, lot of ISO specifications and all that there. We need to make sure, even as a university, if you do data related work, like in our company, we need to go through the data related training for all of us, data privacy related training, not that database type training. I'm talking about data privacy related training, because we sometimes get the client data, how to handle it, how to do that. And uh, company, it is easy because we all employees and all. But if university, just like I was giving example, that you go biscuit company, bakery companies, you do that, ask the data, do that, easy. But again, if we do that, maybe university level, you need to think about that data privacy type, what kind of education is possible for the students, and how we can make the students to be compliant with that. Because if anything goes wrong, some student or someone taking the data from the industry then mishandle that, then it will be the bad reputation for the university also. Like corporate world, we have a data department, data privacy department. We have to go through, even if data privacy breach or anything we notice, then we need to report that, and there is a action steps and everything there. And I believe corporate world, I will say most of the companies, like bigger companies, it's a well structured, well defined processes are there. But I know that lesser known companies, how it is handled, we don't know. Then college, university, when project purpose, we get the data, how it handled, we don't know. So those aspects definitely need to be looked into. Of course. Yeah. Okay. So that's a good point from Raunak Shah, that NEP 2020 in India also. Yes. Oh, no, definitely. I'm sure every country has, as I say, I'm not working in India for a while, so I may not know all the latest updates, but definitely all these requirements and all these are there, and definitely we can all can play role. Any other question or anything if you anyone want to say, whether you find it useful? Because again, I know you all are from academic institute and coming from different angles, so you may think that quite different from what you hear, whether it is useful or not. That would be also helpful for me to know that whether this kind of messaging and this kind of examples how resonate with in the academic field. Okay, if no other question, then I guess.
Okay,
mm,
sir. We just want to, on behalf of the organizing team, I would like to extend our heartfelt thanks to you, sir, for taking the time to share such a valuable insights. And I'm pretty sure we all can learn something out of it, because there is always a connection between the academia and the industry. And definitely we will look forward. And in case we have any other queries, we can like reach out to you.
sure, you can
Ah,
definitely. You have my
oh,
contact, so if anybody wants
yes,
to get in touch with me, I'm happy to have any discussion and thing. Yeah.
yes, sir, sure. And so there is this one small token of appreciation from our side. Kindly, sir, accept it.
Thank you very much. Thank you. And maybe I don't know. Hopefully, you can email me this one, right? Because I'm not taking
Yes,
screenshot
sir.
now.
Yes.
Yeah. No, thank you very much. I also appreciate for giving me opportunity to speak to you. As I said that yes, I was sharing some experience, but for me also it's a learning that how my day-to-day work, how to share with the university faculty members and university colleagues in academic world. So definitely, and thank you for giving me this opportunity. Okay, thank you all, and have a nice weekend, everyone, and maybe some other occasion I will have chance to speak to you again. Thank you. Bye.
Thank you, sir. Thank you so much. Participants, you can leave the meeting.
Professor Shiny, actually, our next session will start at sharp 3:15 p.m. So the participants can stay in the meeting, or if they
Oh,
want to rejoin, they should rejoin by 3:12. Okay.
okay.
Good afternoon, sir.
Hey, good afternoon.
Yeah, so we are waiting for the participant to join. They're almost there. So I see it's already 3:15. However, so shall we start now, or
Sure.
can we wait for one more minute, sir?
So we can wait for a couple of minutes.
All right, all right. Thank you so much.
Yeah, just to check, I hope you're able to hear me clearly and able to see the screen also.
Yes, I can hear you and I can see your presentation as well.
Thank you.
I think it's almost 3:16 now. Shall we begin now?
Sure.
All right. So, welcome all to the final session of the 5-day faculty development program on advanced intelligence and data science, tools, techniques, and application, organized by Department of Computer Science and Engineering in association with Innov AI Center of Excellence and IQSC IEM UEM Group. We are privileged to have among us today Dr. Sandeep Hans, research scientist at IBM Research Lab, India. Sir's research interests includes artificial intelligence, machine learning, AI testing, blockchain analytics, and theoretical distributed computing. His current focus is on LLM agent, building dependable AI system, adversarial AI testing, and data quality. Dr. Hans received his PhD degree in computer science from Technion Israel Institute of Technology and MS from IIIT Hyderabad. Prior to joining IBM Research, Sir was a postdoctoral fellow at Virginia Tech in USA and have worked with Mindtree Consultancy Limited in research and development department at Bangalore. I would now like to invite Sir to kindly address the gathering. Over to you, sir.
Fine. Thanks for the introduction. Hello, everyone. Good afternoon. Hope you have enjoyed all the sessions in this FTP program. So I am working in IBM for the past 8 years, and I have worked on many different technologies, including blockchain, LLMs, testing, model testing, verifying models are correct or not. And now the new technology that has come up is agents, which is not only LLMs, but actually how programs can interact with LLMs directly without actually having any human intervention, and how you can save your data while interacting with LLMs. So I'll be talking on one of the projects that we are doing here on agentic framework for application understanding. So I assume that people have a very basic knowledge of maybe LLMs and very basic may not have enough knowledge for agents. So I'll be giving some basics of agents also. But first of all, I'll start with the use case that why we need agents, and also our specific use case, that why how we started working on it and what are the challenges on application understanding for this specific purpose. This is a study from 2017. Reuters gave this list that there are 43% of the banking systems, they are still built on COBOL. And 80% of in-person transactions, they still use COBOL. And if you have ever done, like whenever you do an ATM swipe, do ATM transactions, there is more than 90% of the chance that there must be a COBOL code sitting somewhere, or that must have hit some COBOL piece of code. And there are more than 220 billion lines of code still in use today. So the reason for this is since financial industry, they started using COBOL in 70s and 80s and 90s. So they have stuck with it. Changing in large enterprises, especially in financial industry or in banks, it's not very easy. So they have worked for that for the last 30, 40 years. But the use case has changed now, and also the whole scope has changed, like how people use these transactions and how COBOL is used. Yeah, is there a question? Okay. So the study also showed that the average age of developers of specifically for COBOL programmers that in 2017 was more than 45. So the average age was actually more than 45, and now it will be more than 50 because it's been like 8 years since this study came up. So that means most of the COBOL programmers, they are pretty very, very senior programmers. They have either retired or they are no longer working on COBOL. And in fact, the studies that most of us have done, or even in the last 20 or 30 years, most of the curriculum from any university for bachelor's, master's, computers, electronics, anything, we don't focus on COBOL. So we focus on modern languages like sometimes C, C++, low-level languages, or Java, which is a high-level language, object-oriented languages like C++ and Java, and now modern languages like Python. But COBOL has suddenly gone out of the picture from the curriculum. But still, the use case is still very relevant because the data is still there. There are transactions which are going on for COBOL, for COBOL code. Now, there's actually a serious impact of not knowing COBOL. So there's a big use case for using COBOL, but there are not enough people or not enough knowledge base in COBOL right now. Now, this diagram really outlines a modern user journey for working with the legacy COBOL system. A legacy COBOL system like the banks or the transactions that are happening around. And now imagine trying to follow this step without any COBOL knowledge. Now, starting at step 1, we might discover the application landscape, but without COBOL expertise, we would struggle to interpret what we find. And in the step 2, when we try to find bugs or refactor COBOL services, it becomes a bottleneck. Without understanding the knowledge, without understanding COBOL, the refactoring introduces a list of errors. There's a risk of errors, performance issues, or even breaking business critical functionality. Then there's actually many projects that are going on for transforming this COBOL code or transforming the COBOL legacy code into modern languages. So, for example, there are projects going on in IBM also for converting from COBOL applications to Java applications. Now, transforming the code for modern architecture, it becomes far more difficult if you don't understand COBOL or if you have very limited knowledge of COBOL. Developers cannot optimize what they don't fully understand. And then validating the transformation, that is the Java code that is being developed or that is being transformed using the COBOL code, the number of test cases that you can generate is very limited, and it may not even reflect the original COBOL logic accurately. And then once you validate the Java transformation or the model language transformation, the recommending architectures or ongoing observations, it becomes incomplete because we are missing key insights into how the original COBOL code behaves. And we don't have people who have written that COBOL code. So the impact of not knowing COBOL or not knowing the legacy languages, it affects every stage of this journey. To truly modernize and evolve legacy systems, so COBOL expertise it's not even optional, it's now foundational. And the thing is, we cannot start learning COBOL at this point of time, and we don't have enough people who understand COBOL. So many enterprises still depend on legacy mainframe applications built in COBOL. Like we saw in the first slide, that there are still a lot of financial services still going on in COBOL. Now, mainframe modernization is about moving the system to modern, modular, and service-based architectures. For example, new languages like Java. And it's important because it helps ensure systems are maintainable, scalable, and efficient as business needs evolve. So the clients that we interact with, or the enterprises or the banks that we interact with, they have very long vision, like a 30, 40-year vision. They want to have the same systems running in 2040, 2030. But they know that COBOL may not be able to, they may not be able to sustain COBOL for that much long. So they have actually a 5-year plan of transforming all the COBOL applications that they have to Java applications. So they are doing it one by one. And it was actually pretty difficult, like you can say like 5 years before. By 2015, 20, it was actually looking very difficult. How can you convert? This is a very challenging problem. But once the LLMs came into picture, like for example, when ChatGPT came into picture, so people have these ideas. See, these languages, these LLMs can understand our language, can understand English. They can understand, some of the new models can understand a code also. Why not we use them to actually transform? Why not we use them to modernize our applications? That's how this whole thing came into picture. All the businesses, even the clients, the banks, financial institutions, that they are getting these ideas that how can we use LLMs, or how can we use all the agentic stuff or all the new technology that is coming up to transform, to have this transformation, so that we can still have the same systems running 20 years, 30 years, or 40 years from now. Now, in modernization efforts, users often need to understand specific COBOL fragments. So like a paragraph or a few lines. So in COBOL, like in Java, we have classes and methods. In COBOL, we have programs and paragraphs and data sections. So a user may come up that the first step is actually the user may come up is for application understanding. I want to understand what this application does. So maybe a bank has a code, they hire a new person. So the new person will come up with a piece of code that the application of the bank still has, and they take up a paragraph and they start asking questions that what does this program do? What does this paragraph do? Where is a variable like exemption set? So which paragraphs or which programs are writing on this variable? Which variables are local? Who calls this program? Which other part of the program or which other part of the application is using this paragraph called para A? So without deep tooling or COBOL knowledge, answering these can be slow and error prone. You may get stuck in actually a large haystack, yet they are critical for safe and efficient modernization. Now, these are challenges in understanding legacy systems. Suppose you have actually a large application of COBOL. So there are a lot of challenges. Manual code scanning is slow because people, COBOL is a very low level language. So it has um, uh, so many statements that it supports that it's difficult to understand and difficult to learn a new language at this point of time. So manual code scanning is slow, especially with very large systems, and banks actually really have very large systems and they are not open. So the code is not open. You won't find a lot of GitHub repos, or you won't find a lot of open blogs with COBOL codes or understanding of COBOL code. So there is a lack of reliable documentation and code comments cannot be trusted because these codes are used for financial institutions. So these codes are secure and these codes are very secretive from the bank's point of view also. So we are also losing critical knowledge. Experts retire because most of the experts who learned COBOL, they learned it like 20, 30 years back. So most of them have retired, and with complex interconnected system, it's harder than ever to understand the full picture. So these issues slow us down and increase the risk. Now, legacy applications, they inherently bring significant challenges. So not only application understanding, but legacy applications. So we are dealing with massive code bases, sometimes millions of lines. We saw that there's still 220 billion lines of code still running in ATMs and other financial transactions. And they are tightly coupled modules that make every change, even a small change, it becomes very risky. And the complexity and interdependencies, they slow us down. They create maintenance bottlenecks and limiting our agility or limiting our ability to move forward with the same application. To tackle these challenges, we need automated tools. They enable faster comprehension, support better decision tasks, and are essential for modernization and refactoring. So with the right tools, developers feel more confident, they can make changes, and we gain the scalability needed to keep up with the growing demands. So this was all about application understanding, that why is it important, and how people have tried to tackle it, and what are the challenges that are there in the current state of application understanding. Now, when LLMs came into picture, the use of generative AI is also gaining significant traction in this space. You take any problem in computer science, so people have tried to solve any problem, not only computer science, but even every domain. So people are using LLMs, people are using ChatGPT, using Gemini, using Granite models, cloud models to do everything. So models can understand natural language, models can understand images, models can understand text, models can understand even source codes in different languages. They can understand Java, they can understand Python. So you can ask any question and they will answer. So the current state of large language models like Llama, Granite, GPT, Mixtral, so these enable a natural language explanation of a given source code. So they understand source code, they can explain that what does this source code do. So while they're useful for getting started, they have certain limitations. For example, they have hallucinations. That is, they can actually generate stuff which may not be true, and you don't have any way of validating that. They may be imprecise. They may not be very precise, especially with the very technical code bases. And many of them actually have limited context length. Some of them are very expensive. Those with larger context length, those for those who which the models you can use for asking very long questions or using very large source codes. So you can actually it becomes very expensive. But the models which are not very expensive, they have very limited context length. You cannot ask questions about very long programs. And also the problem is you cannot give the complete application. If your complete application has, let's say, 500 programs, you cannot put all the 500 programs and start asking question to the model. The model will not understand. The model actually, they cannot even support these many context lengths. So currently, program-based techniques and generative AI are working independently. So there are solutions for application understanding. So there are static analysis-based solutions, so which are actually the current state of the art, which people have tried for like 20 years, 30 years. You can extract insights, but they lack a very user-friendly interface, and they can support only a very specific use case. Why the new technologies like the generative AI or LLMs, they can explain code, but they suffer from hallucinations and they have very limited context length. So both these techniques, so till now, so both these techniques, people have worked on both the techniques using LLMs also, using static analysis also, but they have worked independently. So what we are trying to do is, so can we bring both these technologies, both these techniques, the static analysis, that is the classical technique of understanding the code base, and the new technologies like the LLMs, which can understand code, which can understand the natural language also. Can we bring both of them together and get a better solution? So how can we bring best of both worlds? That is a knowledge base or the static analysis techniques that we already have, and the generative AI or the LLMs that we are new to, but they can understand a lot of code. They can help us understand natural language and code and explain the code also. Now, with the yeah, so this is the first paper that became one of the first few papers that came for agent. So what it says is LLMs are very good at reasoning, and you have techniques which can be very good at acting, that is acting on a specific piece of information. For example, you can do a search, you can do a small static analysis, you can do understand the code just by a rule-based application. So you can do reasoning using LLMs, you can do acting using your own tools. So why not bring both of them together? So they created a framework called React. So it's called reasoning and acting. So I'll just go through one example that they have published in their paper. So this is a paper from ICLR 2023. So this is one of the first few papers where they have built agents over LLMs, and they have used them to not only reason but to act also. For example, if you have a question, something like aside from Apple report, what other device can control the program Apple remote was originally designed to interact with? So this is not a very straightforward question. But if you ask this question to an LLM, for example, ChatGPT, maybe the older version, it will give a direct answer, whatever knowledge it has, whatever data it has been trained on, it will just give a straightforward answer called iPod. But if you have a bit more complex prompt and you try to do a reason, that is called chain of thought. So the LLM may start thinking. So it will think that let's think step by step. Apple remote was designed to interact with Apple TV. Apple TV can be controlled by iPod, iPad, and iPod Touch. So the answer is all of them, which is actually the wrong answer. And if you have your classic tools, like for example, you have a search tool, you can search for Apple remote. It will give a large string. There'll be a phrase there called front row. So we'll search for front row. So it will not find. You will try to find a similar natural language based software called front row software. And you will have an observation called front row is a discontinued media center software, but you won't get the relevant information. You won't be able to reason on all this information that you are getting from these actions, from the search actions. So you won't be able to answer that. While if you have a React agent or a React based framework where you can reason and do act both, then actually you may be able to answer them. So basically, you take the chain of thought or the reasoning part from LLM. You have your own actions where you have your own knowledge base, and you can actually do search or you do some calculations locally, and you can actually get the observation from them, whatever the output your tools or your actions are producing, and you can the LLMs can help you reason that. So the search gave these results, like the search gave all these results, could not find front row, but I could find front row sent to a front row motorsports, front row software. The LLM can understand that, oh, so I could not find a front row, but I found something called a front row software, which is very similar. Let me search that. So it will have this observation. There's actually a large piece of text is there. And then the LLM will be able to understand that from this large piece of text, there is like one line which is very relevant for me. That is front row software is controlled by an Apple remote or the keyboard function keys. So this is the one line that the LLM help us understand, and we are able to answer them. Let's finish keyboard function keys. So all in all, so what an LLM agent is? An LLM agent is a dynamic problem solver. A human gives it a task that I want to know which remotes, which products can be controlled by an Apple report. And the agent uses its large language model as a central brain. So LLM helps it reason. This allows it to reason and leverage various tools for real world interaction. So the knowledge base it has, it could be in terms of maybe a Wikipedia or a large text pieces, or it could be hidden behind a database. And the tools can help the agent interact with the knowledge base. The tools can help extra, like using SQL queries, they can extract in specific information from the database. And which tools to use for a human user query, that is what LLM is helping the agent about. The agent then synthesizes this information to provide a comprehensive, intelligent response back to the user. So the LLM can help agent in two ways. So first is understanding what the human is saying and selecting which tools to use. The agent use those tools to extract knowledge from the knowledge base, from a database, let's say, or from some files. And once it gets these observations, what agent does is the LLM helps the agent to form a natural language answer to the human. So it helps, LLM helps understand which tools to use, and LLM helps agent form the answer for the final user. So this is how the agents work. So LLM powered agents work in a loop of thought, action, and observation. So there's a thought, that is reasoning part, the action that the agent is taking, and the observation. Observation is the output of the tools that the agent has, or output of the actions that agent has taken. And this goes in loop. So there is thought, action, observation, then thought, action, observation, thought, action, observation. The agent starts with the thought, reasoning about the task. What does it need to do? Maybe decomposing the query, maybe planning and breaking it to sub goals, that I need to do this first, then this first, and this first. Then it takes the action by calling the tools such as a calculator. It could be a code interpreter. It could be a search. It could be a SQL tool, which is extracting information from database, or it could be reading from a file, any kind of tool. Finally, it makes an observation. So whatever the tool returns to the agent, the agent uses LLM to understand the observation that, see, the tool has returned this thing. So what should I answer to the final user? So finally, it makes an observation, capturing the result, storing it in memory, and refining its plan. This cycle repeats, supported by both short-term and long-term memory. The agent can actually remember what the user has asked earlier also, until the task is completed efficiently. So agentic frameworks extend AI beyond single response. They use multiple agents working together to solve complex problems. With function calling, these agents can interact with structured tools and APIs. So there are many LLMs which don't have function calling capability. So earlier LLMs, they used to be based on maybe only text based. They did not understand the source program. Then there are LLMs which actually they started developing or actually training LLMs which can understand the code also, and which have function calling ability also. They can tell actually which tools to use, which functions to call, what kind of inputs parameter do you need to give to these functions. So based on that, the agents can take their respective actions. Now, this opens up integration possibilities. For example, combining AI reasoning with static analysis for deeper insights and automation. So the first part of the talk, like first couple of minutes, so I talked about the problem, that is application understanding. Why is it relevant? How is it important? And what are the challenging tasks related to the application understanding? The second part is the solution part, where we found that people have worked on, or the literature, people have worked on a lot of solutions, like old solutions, like static analysis based solutions, or the new gen solutions like LLM based solutions. But agentic frameworks can help us actually use best of both worlds and join them. Now I'll start talking about how we are using the agents to solve application understanding or to solve our use case. Now, this is our proposed solution. So, our proposed solution is an agentic system built on the React framework, that is reasoning and acting framework, implemented with, there is a framework called LangChain, which helps you create agents, and RAG, that is retrieval augmented generation. The React framework enable agents to reason and take actions in sequence. LangChain with retrieval augmented generation ensures more accurate and context-aware responses. And finally, we integrate actually a static analyzer. So IBM has a product called IBM ADDI, which serves as the core program analysis engine. So it can actually analyze the complete application and stores all this information in a database, which can be accessed through SQL queries, which can be accessed through APIs within the agentic framework. So what is this ADDI? So ADDI actually stands for Application Discovery and Delivery Intelligence. What it does is you give your, let's say, application. It could be in any languages. It supports COBOL also. Let's say your COBOL, your application has 800 COBOL programs. So it does as, yeah. Is there a question here? Okay. So what ADDI does is it scans the complete application, let's say 800 programs, and then scans what kind of programs are there, what kind of paragraphs are there, what kind of variables are there, what kind of SQL tables or databases that this application is processing, what kind of uh, variables are written by a program, what kind of variables are read by a program. It scans everything. It actually does analysis on each and every part of an application, and then store all this information in a table, so that whenever a user comes, we don't have to do the scanning or the static analysis of the application again. So, and it has actually an extensive 500, more than 500 tables, I think more than 530 tables. So for example, if you see on the left hand side of this graph, so there is a data section for a COBOL program, and then there is a procedure division which contains the paragraphs, basically the methods for this COBOL program, which has a teacher process, which does something, some computations based on the salary, and similarly a student process, which computes the percentage of marks. And the data division contains the variables or the structures that the COBOL program uses, along with the data types. For example, there is a teacher structure, there is a student structure. That teacher has a name, salary, qualification. Similarly, for student has a student name and marks. So it's a very, very toy application. So what ADDI will do is ADDI will scan all this application, the complete all the programs and all the data divisions, all the paragraphs and procedures, and then create tables like this. So it has a specific tables there. So it has a table, for example, it has a table for variable. It has a table for paragraph. It has a table for statements, for each and every statement, COBOL statement that it uses. And it has actually this cross relations where which variable was read by written in which statement, which line number, which variable was read by which line number. So all these ideas actually you can map using these different tables. So you can see all the variables used by the application, all the paragraphs there in the application, all the type of COBOL statements that are there in the application, including the if conditions, and all the relations that it has between, like, for example, paragraphs and variables, which paragraph is writing, which paragraph is reading. Now, this is a high level architecture of our agentic system invoked through a chat interface. we use models which understand the source code and which actually have function calling ability. So agent has an LLM which it uses for reasoning, and the knowledge base that we saw in the agentic framework is EDDI for us. So there is actually an extensive database there, which has more than 500 tables for any application. And the tools that the agent has are all these tools. For example, the paragraphs which are performed by a given paragraph, or programs which are called by a given program. So there is actually a small Python function which creates a SQL query which extracts the information that these are the programs which are called by this specific program, or these are the programs calling another program, or list of all the paragraphs in a given program. So these are all the tools. Along with this, some metadata information like the number of programs in the application, number of paragraphs in the application, or the number of tables used across the complete application. Or there could be tools for a generic NL to SQL. Uh, Now, so it actually looks like a very easy picture. You take any framework and you take any agentic framework, you put your knowledge base, could be database, could be like SQL queries, and you put one LLM with it, or like a decent size LLM with it, and you will solve your problem. But that's not the case. So there are actually a lot of issues with that, or a lot of challenges actually, even in agentic frameworks. Even if you have a very strong LLM, even if you have a very large knowledge base, you still have lots of problems. For example, so I'll tell you our experiences with that. So for example, the agent can interact with the database using fixed set of tools, or using fixed set of SQL queries. For example, we have 500 tables in EDTA. Maybe we'll use 400 or 300 tools to get some specific information that we are looking for. But when you take all these 400 tools and you give it to LLM, see, this is what user is asking, and these are the 400 tools that I have. Can you tell me which tool should I use? Which actions should I take? The LLM will get confused, or the LLM may give wrong answers, or it will actually cross the context line because you're giving the description of 400 Python programs. So that's a problem thing. So one solution to that we have explored is a tool pruning technique, which the agent uses before going to the LLM. So whenever a user query comes, agent itself has some very small, a small model, or actually a small tool. What it will do is it will take all the 400 tools and do a tool pruning. It could be a very rule-based solution which can tell that all these 250 tools are not relevant for you. For example, if the user is calling about a table, then the agent does not need to look into the programs or the paragraphs uh, or variables tools. So it can only take like 10 or 20 tools which could be relevant and then give it to LLM. So this tool pruning actually is a very crucial activity. And the second thing is, so when a user comes and asks a question, the user can be asking the similar question again and again. The user may be asking about the same program, for example. It may be asked, the user may come up and say, see, what are the tables used in a program called LGCDB? And then, okay, so tell me which variables are used in this program. Tell me which other programs are used in this table. So generally, when you ask a question, in fact, in our experiences also when we are interacting with LLMs, so we keep on asking the same question again, a very similar question. So we actually have a conversation like natural humans have. So in order to expedite the user experience, so we can actually do a small kind of a caching. So we can keep a data structure, the data structure that you can see on the left-hand side of this graph. So you can have a data structure which will extract a relevant piece of information which the user is asking again and again. And you don't need to do a SQL query or a SQL connection to the database again and again. You can actually just answer from the data structure. So whenever a user query comes, you can see if the tool can answer from the data structure itself rather than every time going to the database with the SQL queries. So this is how the complete architecture looks like when we have all these techniques, including the tool pruning techniques, including the data structure, the caching techniques, which has its own program analysis modules, and all the tools that the agent is using. Now, these are the key functionalities of the agent that we have. So the first thing is actually is where agentic framework brings a lot of information or a lot of positive outcomes with the chat experience is query decomposition. So it can break complex queries into structured calls. So LLMs can understand a language very well. So they can help you reason that what are the steps that you need to take. For example, the query is which programs access same table as accessed by the current program LGCTPO1. That's what the user is looking for. Now, you don't have a tool to actually answer this specific query. So what you will do is, so the LLM will tell agent, you need to use two tools. First step, you need to get all the tables which are accessed by this program called LGCTPO1. And in the second step, once you get the tables which are used by this program, then you need to use another tool and uh, uh, get information on which programs access this table, access the table which are accessed by LGCTPO. So for example, when the agent acts on the first query, which tables are accessed by LGCTPO1, the answer is, let's say, customer table. So there is a table called customer. And then the agent does a second act, a second action, or actually a second tool calling, which is based on which programs access the table and the parameter is customer. So this parameter, it got as the output from the first subquery or the first tool calling. So the first observation returned customer, and then the agent thought on it. And then the second observation is actually which programs access the table customer. So you can actually decompose it very well. For even if you have queries like list all the paragraphs of a program that use the table customer. So the first subquery or the first decomposed query is which programs use this table customer, and the answer, let's say, is LGCTBO1. And the second tool that the agent needs to call is list all the programs in this paragraph in this program called LGCTBO1. So this is how the agent actually helps a lot in understanding the application and understanding a very complex user queries. So you cannot have all the tools for every, you cannot have one tool for every user query that the user says. You can have like 40, 50 or 100, 200 tools. So whenever a user comes up with a query, you decompose and you see which of the tools out of this 550 or 100 or 200, maybe there is a sequence of tools or two tools or three tools that you need to invoke, that you need to act on to extract this information. Another thing is, even if you have this 200 or 300 tools for the 500 tables that ADDI has, these will still not be enough. The users can always come up with any natural language query, which may not be enough for the tools to answer. So then there is work on NL to SQL. Whenever you give a natural language, it can convert into the into SQL queries. It can actually takes natural language query and converts them into SQL. Now LLMs based solutions are also there, and there are old solutions also which use the database schema. So this technique can be used to actually take any natural language from the user, extract the query, get the SQL query that you need, and just ask ADDI directly that what should be the answer of the SQL query. So this kind of tools can also be built. Another key functionality is context awareness. So uses chat history for follow-up queries. The user may keep on asking questions, similar questions. For example, what does this program do? Then the agent answers. Then based on that, the user will ask, okay, which of the tables are used in this program? So whenever the user uses a pronoun, for example, this, the agents from chat history understands that this refers to a program that the user has asked earlier. For example, LGCTP was the program that the user has asked earlier. So this refers to the program called LJCTPO1. Then let's say that tables come up that it uses customer table. Then which of the programs use this table? In this case, the user will understand or the agent will understand this refers here to a table which LGCTP uses, which is customer table. So this will actually uh, map to the customer table. This is how the chat history can also be used for follow-up queries. The user may not be giving the complete information every time. The user may be referring to information that he or she has asked in the previous interactions or in the previous queries. Now, these are some of the tools that we have. We actually have a list of large number of tools, but this is just an example of the tools that we have. Like, for example, listing all the available programs in the application, listing paragraphs given in a given program, getting data division, which variables are used, which paragraphs are called by a given program, listing the set of jobs, listing set of transactions, or there's a whole call graph, which paragraphs are calling which other paragraphs. So all this information is, all these are actually the tools that the user has, that the agent has access to, and the user can ask agent about any of the queries related to these tools, which can use one or multiple of these tools. For example, we actually have built a VS Code extension also, and on the left hand side in the white background, you can see actually a sample the agent interaction. The user is asking what programs are called by a program called LGCTBO1. The programs called by LGCTBO1 are all these programs, and which programs use a customer table. Then out of these programs, the programs that are using customer table are all these programs. Then get tables used in LGCTBO1, you get the table is customer, which paragraphs are performed, list the set of jobs, and maybe the answer could be a negative answer. It may not have to answer every time. The answer could be there are currently no distinct jobs. So these are the kind of user interaction or user queries that that can be performed using the app insights or the agent that we have. Uh, Now, the IBM ADDI database of how we have interacted is, so it actually powers application understanding because it stores all the information in the database which can be accessed at any point of time. We don't have to do a static analysis, or we don't have to do scan the application, or we don't have to use the source code. So the best part is actually uh, the agent, since it uses ADDI database, it does not need to actually use the source code that the user is talking about. We don't even need the source code because EDD has already scanned the complete source code and put every information, whatever is required for the agent in the database. And it reduces reliance on manual code analysis. We don't even need to manually go to the code. We don't even need to see what this code is doing. We can directly start asking questions about the application without even looking at the code. Now, deploying agentic solutions as a software as a service, it actually helps. It has a lot of positive impact. So it gives access to actually a large user base. So everyone can come and use the agent through APIs. You just log into the cloud. You have your cloud on AWS, or you have your cloud on IBM, and you can just start using the agent. Maybe the database is already there in the ADI database. Maybe it can be hosted in cloud, or you can also have LLMs which are already hosted in cloud using, and you can access them using APIs. So all these different modules are there, and actually you can just plug and play around with the agent. I want to use a different model for my agent. I want to use a different tool. I want to add a different tool. So all these things become very easy when you have a cloud-based solution. Now, there could be a data privacy or scalability issues because when enterprises start working with their private data, maybe they have information on their customers or on their employees. So they want to protect all this sensitive information. They don't want this information to go to a SaaS-based solution or a cloud. But it still makes integration very easy for the developers. Now, looking ahead, we see 5 key areas of advancing AI-powered application understanding. First is reducing hallucinations to improve accuracy. So many of the LLMs that we interact with, especially when we talk, when we ask about a very specific use case or a very specific code piece or a very specific tool, they sometimes they start hallucinating the answers themselves without even going to the tool. So one is actually reduce hallucinations to improve accuracy. Second is better context management through stronger memory and retrieval. Third is enabling seamless human AI collaboration to build trust and usability for developers, because we need the security and we need the data privacy also. And fourth is optimizing the performance. So, for example, the tool pruning techniques that we have used, or the caching techniques, that is extracting some specific information even before the user start interacting with the agent. So those kind of techniques can optimize performance and reduce the latency, and it actually balance speed with the cost. And finally, ensuring security and compliance when working in sensitive enterprise code. So most of the enterprise code, especially since our clients are dealing with banks or with financial transactions, so the data is almost always very sensitive. So we need to have security and we need to comply with that. We don't want to use a model which can use that data to train itself or which can extract the data. For example, if you are using ChatGPT, you are not sure where the data is going, where your personal data can go, and who actually can see it or who can use it further for training for the models. Now, compared to traditional approaches, our agentic framework offers clear advantages. So by combining techniques like static analysis with AI agents, we achieve a much more robust understanding of the applications. This allows faster query processing and decision making while also being more scalable and developer friendly. So during our implementation or during creation of our agents, we uncovered several important lessons. So it's not a very smooth curve. It's not very easy to just take a framework and start building your agents. We face challenges in integrating large language models smoothly into the workflow. The model has to be very specific. Sometimes the models are very sensitive about the prompt, especially when they are talked about legacy languages like COBOL or about programs or the tools that you are using. So we have to be very careful whenever we change the model, even when we are upgrading the same model. So we face the issues. We also learn the importance of balancing automation with human oversight to maintain trust and accuracy. The kind of data that the agent gives to the model, or the kind of works, or the kind of validation or the test that the agent actually assumes with the LLM. So these are the balancing things that we need to see, that how much work can we overload this LLM with? Are we using it only for checking which tools can be used, or can we use it for some other purpose also? And finally, we discovered areas for performance optimization that improved efficiency of the overall system. So we improved the efficiency, or we actually optimized the performance using tool pruning techniques, using caching techniques, using creating our own local data structures. So these kind of techniques can help a lot, especially when you have very large scale enterprise applications. Now, looking to the future, our focus is on three directions. Now, first is enhancing AI explainability so that like developers can clearly understand how decisions are made. So it's not, the agents are not just a black box for them, that they don't know what is happening underneath. Maybe the developers will be able to see that these are the SQL queries or these are the tools. Maybe some information that we can explain to the user, that how the AI has come up with this answer, that which kind of tools or which kind of actions, which kind of observations that it has seen. Maybe it can
Uh, Sir, can you hear us?
yeah, I can hear you. Yeah.
Yeah.
Yeah, sorry, I think I got disconnected.
Yeah.
Can you see my screen again?
Yes, sir, we can see it
Yeah.
now.
Yeah, anyways, I had just have two more slides. So looking to the future, so our first goal is enhancing the explainability, that we can explain how the AI or how the agent has come up with this answer, which is currently lacking in even LLM based solutions. Second is adaptive learning from enterprise data to continuously refine the process. Like whatever feedback we are getting from the user, whatever kind of observations that we are getting from the database, so we can actually improve continuously, refine the performance of the agent. Like the LLMs can keep on training themselves again and again and again. So we can also, the agents should also be able to update themselves with the data that is coming. And third, developing more secure AI models to protect sensitive systems and code. The enterprises, they have a lot of sensitive information, sensitive data. So how can we save them from going to the LLMs, or how can we actually keep them behind a screen for the LLMs, so that LLMs don't have access to the code. Only the agent sees the code, only the agent has access to LLM. So how can we keep all these sensitive data separate? Now, this is my last slide. To wrap up, there are three key takeaways. First, agentic framework can bring together two different domains. For example, they can bring AI, LLMs, and static analysis, enabling deeper application understanding. Second is our proposed system directly supports modernization of legacy applications, making them easier to evolve. And third is deploying some such solutions in enterprises. There are a lot of challenges addressing real world challenges like trust and performance and compliance. Uh, yeah, so it's not very difficult to create agents. Agents are very powerful. There are a lot of frameworks that are already available there. The models are already available. There are free models and open source models also. So it's not very difficult to do, but there are certain challenges and certain techniques that we can do to make the agents more powerful and optimize them. So that's it for today. Yeah. Thank you, and let me know if you have any questions on this one.
Participants are requested to, post their queries in the chat box. Sir, I think there are a few questions right now in the chat box. Should I read it out or?
Yeah, sure. Yeah, let me see if I can actually.
Meanwhile, I request all the participants to post their queries in the chat box.
Yeah, so these are the questions that you're saying, right?
Right.
Right. So in how can we make LLM agents more reliable given their tendency to hallucinate? Okay, so this is actually a very good question. So there are a couple of ways of doing it. So one way is using the LLMs. The second way is actually on the agentic side. Now on the LLM side, so the ways that we are doing it, so there are certain parameters there. For example, there is a repetition penalty, there is temperature. So depending on your use case, you need to refine those parameters a lot. So we actually have done a lot of hit and trial methods for refining those parameters. For example, some of the models, they were trying to repeat the same tools again and again. So we increase the repetition penalty for those models. And sometimes the use case, for example, our use case is mostly fact-based. So there is a specific fact that the user is looking for, and we don't need to be over smart. We don't need to be have a very flowery language for the user. So it's just a stat based, just simple statistics and very short answers. That's what we are looking to give. So we kept the temperature also very low. So these kind of parameters actually can just play around with the parameters. That can help. Second thing is from on the agentic side. So for example, the React framework, there are multiple frameworks. The React framework, they have their own prompt. There's a specific React prompt. When the agent asks the LLM, see what these other tools that I want to use, what should I do? So you can actually improve that prompt. So you need to actually do a lot of prompt engineering. So we did actually in earlier stage, especially with smaller models, we did a lot of prompt engineering also to understand what the LLM can give. So it used to make a lot of mistakes, but when you refine the prompt, you can keep refining the prompt actually. So that is one key takeaway. So prompt engineering plus model parameters, these two things can actually help reduce the tendency for models to hallucinate, especially for aesthetic work. Yeah, so then there is a question on, I checked in the site that a free trial is going on. How is it limited based on number of days or number of queries? I'm guessing you're talking about how when you access the models, um, um, what kind of token usage, or is there any, what kind of limits are there? So one thing I understand is there is a limit on the tokens. It's not the queries that you send, but the number of tokens that you send to the model. And uh, the non-free applications or the non-free tools that you have for LLMs, they are based on token usage. Like per 1,000 tokens, I think per million tokens, it's 0.20 cents for Granite models, 0.80 or I think 0.60 cents for Llama models. That's what I remember. So most of these interactions are based on them. And then there are many actually open source models that you can use. So for example, uh, Granite models, IBM Granite models are open sourced. Then recently, ChatGPT. So they have open sourced. I think just a couple of weeks back. I think 1 week back, they open sourced two of their models, GPT 12 billion and one more model. So you can use those. You can check those models. Llama is anyways open source. You can just download Llama on your laptop and run it. The smaller models you can run with your CPU. Also, you don't even need a GPU for that. So yeah. So any other question? Yeah.
All right, so thank you, sir. If there's any more question, you can post it even now. And so, meanwhile, I would like to, present our plug from the organizer team. So, can I share my screen now once?
Sure, sure. Please do.
I think, yeah, thank you so much. All right, so I hope it is visible now. So I would like to present the token of appreciation, to sir, and sir, we would be mailing you the same plug through to you. Thank you so much for being here, and particularly one second. Yeah. So particularly for explaining us right from the scratch, from the explanation of the application until the structure, the system architecture, until the challenges of the agentic frameworks. Thank you for giving us this time. We are honored to have you here. We have our head of the department, Professor Dr. Moon Singh ma'am here. Uh, if ma'am is here, I would like to request ma'am to address the gathering.
Yeah. Am I audible, Shubhasri?
Yes, ma'am, you're audible.
Yeah, yeah. Thank you. First of all, I would like to thank Ms. Dr. Sandeep Hans for this wonderful lecture. Thank you so much, sir. And we have come to the end of our 6 day long faculty development program. So, good evening, everyone. It is my privilege as the head of the Department of Computer Science and Engineering, Institute of Engineering and Management, Kolkata, under the University of Engineering and Management, Kolkata, to deliver the valedictory address of this 6 day long faculty development program on artificial intelligence and data science, tools, techniques, and applications. Over the past week, we have been fortunate to engage with a distinguished panel of speakers. From academia, we had Dr. Sailesh Suryanarayan Iyer, Principal, Narnayan Shastri Institute of Technology, Ahmedabad; Dr. Saptoshi Goswami, Assistant Professor, Bangavashi Morning College, University of Calcutta; and Dr. Chandan Chakraborty, Dean and Professor, NITTTR, Kolkata. We also heard from Dr. Tirthankar Dasgupta, Senior Scientist, TCS Research, Dr. Dinesh Khandelwal, and today from Dr. Sandeep Hans, Senior Research Scientists, IBM Research India. From industry, we had Mr. Rajat Chakraborty, General Manager, HCL Tech; Mr. Muhammad Saqib, Associate Cloud Infrastructure Architect, Amazon Web Services; and Mr. Souvik Dutta, Sector Lead, Engineering and R&D Services, Capgemini, UK. Their presence and insights enriched this program immensely. At this moment, I wish to acknowledge with deep gratitude the guidance and encouragement of Professor Bonani Chakraborty, who is the president of IMUM Group, and Professor Dr. Satyajit Chakraborty, director IEM Kolkata, for their constant support. I also sincerely thank the Innov AI Center of Excellence and the Internal Quality Assurance Cell IQAC of IMUM Group for their collaboration in organizing this FDP. I extend heartfelt appreciation to my co-coordinators, Professor Dr. Sukarna Mukherjee and Professor Anindita Das Bhattacharjee, as well as the organizing committee members, Professor Shubhasree Roy, Professor Sangita Sarkar, Professor Shayuni Chatterjee, and Professor Ronak Shaha for their dedication and hard work. Finally, I thank all the participants for your active involvement and enthusiasm. Your encouragement has made this FDP meaningful and successful. As we bring this program to a close, let us carry forward the spirit of collaboration and continuous learning that it has inspired. Thank you all.
Thank you, ma'am. Thank you for the valedictory address. I
Thank
would
you.
now, yes, ma'am. So now I would request all the participants to, kindly note that the exam will be on Monday, the next week, and the timing will also be communicated to you through the WhatsApp group of the FDB. Kindly have a look there. And thank you, sir, for being here with us. We're looking forward again to meet you in another such event. Sir, you can hear us. Uh, Dr. Hans, sir, can you hear us?
Yeah, Shubhash. Yes. Yes,
Yes,
ma'am.
sir. So we were actually privileged to have you today in the session, and we look forward to hear you again in some of the events upcoming in our organization. Thank you for your time, sir. Thank you, everybody.
Thank you for the invitation, and it's been an honor and actually a privilege to be here and talking to such a great in such a great FTP program. And I would like to continue interaction with you and with the program and with the workshop also. Thank you.
Sure. Thank you so much, sir. So participants, you can leave now, and we would be taking your attendance through the presence in the meet. Just a reminder that we would be having the exam on Monday. The time would be communicated to you through the FDP WhatsApp group. Kindly have an eye there. Thank you, everybody, and have a great day ahead.